When it comes to data processing, few tools out there can match the power and flexibility of the Pandas Python package. And most of that power is due to just two classes, the DataFrame class and the Series class. Hi, and welcome back to the Edlitera channel. I'm Claudia, and today we're going to start our Data Processing with Python series. The lessons in this series are led by my colleague Cyprian, who is a machine learning engineer and instructor at Edlitera. In this video, Cyprian will introduce DataFrames and Series. Specifically, he will focus on the fundamental concepts behind these two types of Python objects. This video is part of our in-depth Data Processing with Python course. This course is part of our library of on-demand courses, over 200 hours of videos and hundreds of practice exercises and projects, which you can find on our website at www.edlitera.com. And now let's jump into today's lesson. If you enjoy this video and find it useful, please give it a thumbs up and subscribe to our channel.
In this video, we will introduce the DataFrames and Series classes. These are fundamental Pandas objects. They represent 2D or two-dimensional data in the case of DataFrames. So essentially, we're talking about tables, and one-dimensional data in the case of Series. And they have lots of functionality. We're going to explore these two types of objects in great detail in the course, and you'll see that they're extremely powerful. And they allow you to do everything that you can do with Excel and much more. So first of all, let's try to have a visual understanding of these concepts. I always like to introduce data types using some sort of metaphor or some sort of visual thing that we can all relate to. And we're going to do the same thing in the case of DataFrames and Series. And here's how you can think of a data frame. It's just a table. In fact, this is an actual printout of a data frame that we will encounter later in the course. Let's look at the components of a data frame. We have, of course, the data right here. You can see that the rows are highlighted. And then we have column names right here. They are in bold. This data frame has 1, 2, 3, 4, 5, 6, 7, 8 columns. And then we also have these numbers right here. This is not a data column. These are row index labels. So what are those? Well, these act just like column names except for rows. So essentially they are, if you want, row names. We call them row labels, okay? So that's a data frame. Now, in addition to just the data frames have indices. So what is an index? An index is an object that can be used to access data in a data frame. Indices can be nested. So let's see what an index might look like. So we have the same data frame as before, the same table, except that you can see that we are referring to the collection of column names as the column index. Similarly, we are referring to the collection of row labels or row names, typically we call them labels, as the row index. So these indices, the column index and the row index, are just objects that contain collections of labels that can be used to access specific parts of your data frame, right? So I could use the column index object to, for example, access the empathy column, because empathy is one of the available column names. It's one of the strings, one of the labels that is part of this column index object. Similarly, I could use this integer 2 right here to refer to the third row in my data frame in this specific scenario. And this integer 2 right here is part of the row index object, okay? But we said that indices can actually be nested. What does that mean? Well, you've already done this in Excel, right? In Excel, you can merge cells, essentially, and what you are creating is a hierarchical or a nested, a multi-index. So let's see an example right here. This data has been pivoted, right? And it's been grouped. And you can see that we have a courtesy column right here and 2 dates. And by the way, for the specific data set, let me scroll up right here. So this data set contains some fictitious data that I generated. And the idea behind here is that these are the results of running a customer satisfaction survey. Imagine that we are a big corporation. We have a bunch of stores. Some of them are brick and mortar stores. Some of them are just web properties. And twice a year or perhaps once a year, we send out the survey to all our customers who have interacted with our customer representatives, and we ask them about their experience. We ask them about whether the representative was helpful, courteous, empathetic. We ask them what their overall satisfaction with the interaction was. We ask them about their satisfaction with our facilities, and this facility can refer to, again, a brick and mortar store or a web property. Okay, and then of course we have the rep ID, which refers to the actual representative who helped the customer, and this help could have been provided via chat if the location was online, or in person if the location was in store. So if the customer and the representative interacted in real life, okay? And then we have the date when we collected the survey, right? So this is essentially what this data represents. And of course, we can group this data, we can pivot it. For example, we can group it such that we collect the courtesy, empathy, and helpfulness scores separately for the year 20 2018 and the year 2019. So we see two columns right here. And further, we can also group it by the representative, right? So we have the representative right here, and then we have the three locations. So NA just means that for that specific survey entry, we do not know the location specifically. Let's assume that that's the case. Obviously, if this happened in real life, we would like to go back and understand why we have missing data, because it should be pretty clear. Was it in the store, or did they interact online? But I added a bunch of NA values there because later on I'm going to show you guys how we can handle missing data scenarios, okay? And of course, we have averages right here. So this number right here, for example, represents the average courtesy score for the repo with ID 1121 for the year 2018 and an unknown location. That's how we would read this number. So what we notice here is that we essentially have two layers in our column index, right? So courtesy, empathy, and helpfulness. So these metrics represent one layer, and then the specific date represents the second layer. And similarly, for the row multi-index, we have two levels right here. We have the rep ID values right here and the location as a second layer. So in this case, to access any specific data item right here, to access any specific cell in this sheet, if we use Excel lingo, then we need to use both layers of the column multi-index, right? So I need to specify whether it's courtesy or empathy, and then I need to specify the year, 2018 or 2019, and that will give me a column. And then to identify a unique cell, of course, I need to specify a row. How am I going to do that? Well, I need to specify a value for the rep ID and a value for the location. Is it NA, online, or store? Right? So we can create these hierarchical indices, which are extremely useful for grouping data and for quickly accessing data. And we'll learn everything about multi-indices. We'll learn how to create them. We'll learn how to access data that's been indexed this way later on in the course. Similarly to data frames, we also have series, and series represent one-dimensional data structures. You can think of a series as an array of data, so those are the actual values, plus an array of labels. The collection of labels, again, create what we call an index. Now, series can contain data of multiple types, can be built from a list, a dictionary. We'll see various ways of constructing series objects. You can think of a series as a data frame column. And we'll see later on that when we extract columns from a data frame, what we usually get is a series object, unless we extract several columns at once, in which case we would get a different data frame object, just a smaller one. Okay, so this is what a series looks like. This is how you can visualize it. You have your values, and then you have an index right here. And this index, again, these are just labels. It so happened that in this case, they are integer, but we'll see later on that there's nothing preventing us from using timestamps as index labels, from using strings as index labels. Pretty much whatever makes sense for our data, we can use that. Okay, so this is an example of a numerical index for a series that contains also what appears to be numerical values. But we'll see later on that both series and data frames are actually very flexible. They allow us to store a variety of different data types. For now, what I want you guys to remember is that a data frame is an object in which we can store two-dimensional or tabular data, and it's made up of different parts. We have obviously the data, and then we have a row index and a column index. And these column and row indices, we'll see, they essentially are objects that are attached to the data frame, and they allow us to quickly zoom in on a particular subset of the data that we are interested in. In Excel, we also have column indices, so we have the column names that we create. But if you think about the Excel sheet itself, we cannot really change the column names, right? We have the column names A, B, C, D, and then it starts wrapping around, right? AA, BB, etc. So those are the columns that we have. With data frames, we can create our own columns, and we can nest columns. So we can create these hierarchies that are going to make it a lot easier for us to access data that has been grouped. And we can do the same thing for row indices.
I hope you enjoyed this video. If you found it useful, please hit that like button. It really helps us grow the channel and make more content like this. Until next time, happy coding!